Welcome, fellow prospectors. You've mastered placer gold, but what about the gold hidden just out of sight, concentrated by millions of years of natural chemistry? That's Supergene Gold. This guide is your next step, practical, field-based knowledge to spot these hidden treasures. Supergene enrichment dissolves gold from primary ore, moves it downward, and redeposits it in richer, more accessible zones. Many legendary gold rushes began with these enriched layers, just below iron-stained outcrops. We'll show you how to read rocks, soil, and color to pinpoint where Supergene Gold hides. Forget luck. Arm yourself with a geologist's eye and a detective's mindset. By the end, you'll see the land's story, weathering, chemistry, and hidden bonanzas just beneath your boots. Let's dig in and uncover the final clues to finding that beautiful Supergene Gold. To find Supergene Gold, you need to understand its journey. It starts with a primary gold deposit, often a quartz vein with gold and sulfides like pyrite. Rainwater and oxygen break down these sulfides, creating acidic solutions that can dissolve gold. This gold-laden water trickles downward through cracks and porous rock. The upper oxidized zone, or gossan, is often stained red, yellow, or brown, evidence of this process. Most gold is leached from the gossan, carried deeper by acidic water. As the solution moves down, it eventually reaches the water table, where chemistry changes. The water becomes less acidic, forcing gold to drop out and re-solidify. This is how nature concentrates gold into high-grade supergene blankets. The richest deposits are often just below the barren, rusty surface. Understanding this invisible migration is key to finding the real prize. Gold-rich solutions follow natural pathways, faults, fractures, and rock contacts. Fault zones are highways for water, making them prime targets. Where porous rock meets impermeable layers, gold-laden water stops and spreads, creating rich deposits. Shear zones, bands of broken clay-rich rock, can both channel and trap gold. Breccia zones with their sponge-like structure are classic hosts for supergene enrichment. Look for linear depressions, changes in soil color, or distinct vegetation, surface clues to these structures. Recognizing these traps gives you a huge advantage. When you find a brecciated quartz vein or fault, you're in the right place. These geological features are nature's gold catchers. The Earth speaks in color. Learn to read it. Reds and yellows signal iron oxides from sulfide breakdown, marking the gossan cap. Intense staining means a pyrite-rich source and active chemical processes. Black manganese oxides, often sooty or dendritic, suggest you're nearing the enrichment zone. Green and blue stains from copper minerals indicate a mineralized system. A mix of these colors, red, yellow, black, and sometimes green, marks a textbook supergene target. These colors are more than pretty, they're a treasure map. Follow the rainbow, and you'll follow the gold. Nature's palette points the way to hidden riches. Once you've identified a promising area, it's time for smart sampling. Don't dig randomly. Target gossans, faults, shear zones, and rock contacts. Break open rocks, look for fresh surfaces, and focus on clay-rich seams or manganese-stained layers. Label every sample with location, rock type, and observed colors. Build a geological map from your samples. Patterns will emerge. Crush and pan samples in the field, watching for fine, mustard-colored supergene gold. Even a few tiny colors are a great sign. For more certainty, send samples for lab assay. Systematic sampling turns prospecting into science, not guesswork. The right sample in the right spot can reveal a hidden bonanza. All your work leads to one goal, finding the supergene enrichment zone, the sweet spot. This is usually just below the oxidized gossan at the old water table. Look for a transition from rusty, leached rock to less altered material. Black manganese stains, secondary copper minerals, and clay-rich layers are key clues. The gold here is often dull, mustard-colored, or coated, easy to miss if you're not looking closely. The boundary between oxidized and unoxidized rock is where gold accumulates. Old mine shafts or shallow workings can reveal this layer. Check just below where others stopped. Digging into soft, black-stained clay beneath hard rock? You've likely found the sweet spot. This is where nature's chemistry has concentrated the gold. Pinpointing this zone is the ultimate reward for reading the land's clues. Much supergene gold is microscopic, too fine to see or pan. Use a sensitive metal detector to scan gossans, fractures, and enrichment zones. Listen for signals in material from below the gossan. These often mean pay dirt. When panning, look for heavy mineral concentrates, not just visible gold. Associated minerals like galena or native silver are valuable pathfinders. For the dedicated, simple chemical tests like stannous chloride can reveal invisible gold. Even without visible gold, these methods confirm you're in the right spot. Sometimes the richest gold is the hardest to see. Successful prospecting is a skill, not a lottery. Reading the land, colors, faults, rock changes sets you apart from the crowd. Every trip is a lesson, every rock tells a story. Apply these principles to develop your own treasure map. Take notes, sample, and document. Your experience becomes your best tool. Over time, you'll spot patterns and develop a prospector's intuition. The real journey is learning and honing your craft. Go into the field with knowledge, not just a pan. Combine hard work with geological insight and you'll target gold intelligently. That's how you unlock the true potential of supergene deposits. Good luck and good hunting.